today's session I'm really excited about. Physical stack, physical AI. We're talking about the full stack end to end. It's a very good, rare opportunity where you get to have esteemed guests that can talk through the entire workflow of the opportunity of the physical AI, right? So not just the vision, which we're hoping Jumbi can set for us, and then the connectivity layer, which is critical, that Zev is going to talk about. And then lastly, John is the guy who does the stuff, right? Everything we talk about, he actually has to do, implement it, so a lot of real conversations from his side. So with that, let me start with some introductions. Who am I? My name is Asad Hasan. Right now, I'm with Amazon Web Services. I manage their entire global ISV ecosystem for smart cities. I am also leaving AWS, and I'm starting my own consulting practice, Smart City Consulting. I'm focusing on go-to-market advisory for a lot of the tech companies around here, working with cities, helping them build RFPs and connect the vendor side to the city side, and also looking at doing AWS migrations, because my background has been in 8 years at AWS, and prior to that, I was IoT sales for Cisco. The last 2 months, I've been focused heavily on just playing with IoT AI tools, which has been extremely exciting, right? Because when I was working with the big companies, we had to focus on the infrastructure stuff, but now I'm building stuff, and I've never coded in my life, but just playing with Cloud Code and Cloud Cowork is just wild, the kind of things I can build, right? It's kind of scary. But with that, let's start with some introductions. Zev, if you want to kick it off, please.
Sure. I'm Zev Suissa. I'm the Chief Growth Officer of X-lumin, and we provide ground-to-space and terrestrial-based laser communication. So it's the exact same beam of light that you put inside of a fiber cable, but now we can do it wirelessly. And when you look at all these cool technologies and features and capabilities that we're going to talk about a little bit today, they're all great, and they're very exciting when you think about the feature perspective, but the key component is how do you get that data? That's this tripling amount of data demand that you're going to experience. How are you going to get it from point A to point B? Microwave's kind of reaching its physical capacity of limit, and so you've got to go optical, and you've either got fiber, which is high cost to deploy in many areas, rivers, railroads, rocks, or you're going to have to go wireless fiber, and that's where we come into play.
Yeah, my name is Jumbi. I'm in charge of a business at NVIDIA for smart cities and local government. So NVIDIA, for those who might not have heard of the company, we make software and hardware infrastructure to run AI.
Yeah, John Lockhart with SHI, System Integrators. I've been in the smart city realm for 15 plus years, doing IoT, doing different smart cities based out of Singapore. I recently moved back into the US side of it, based out of Austin, and have done a lot of great projects all across the world. So excited to be here, excited to help you guys understand intricacies of different projects and how we can really deliver that in a way that results in outcomes that the actual people that funded the project expect. Thank you.
Thanks, gentlemen. So the first thing I want to ask you guys is, in the last 12 to 18 months, right, there's a lot of AI excitement around there. From your perspective in physical AI, what is the one thing that makes it real for CIOs, city mayors, anyone, right? What is that one change that has happened? Jumbi, if you don't mind, we'll start with you.
Sure. So, in my world, if you think about physical AI, there's I think 3 big buckets of applications. One is around perception. One is around the ability to simulate scenarios. And the other is around generation, where you can use natural language to query, what's happening in the city. The biggest change in technology, of course, everyone's heard of large language models for, generating all kinds of information. But the biggest change is around vision applications. So as you guys probably know, there are cameras in every city for all kinds of safety, security, traffic management, infrastructure, etc. For the first time now, we have the ability to run what we call a vision language model, which is, think of it as a large language model for the real world. So the ability for cameras to actually understand what's happening in the real world has never been possible before. It has been possible in silos. So there are some applications around safety, security, which you develop a bunch of applications, some around intelligent traffic management. But now, with a vision language model, you can pretty much cover every application and be able to get information from it using natural language. That's been the biggest change, at least in my world.
And we're actually seeing a lot of, I was walking around the floor, we're seeing a lot of companies that are doing a lot of that, right? They have sensors that are putting on phones, they're putting them on fleet management systems and capturing all that video and getting a lot of insights, which previously you just didn't get, right? Basic AI didn't offer that to you, so you're right, vision is definitely a game changer. Zev?
And I'll keep it focused to the connectivity part, right? Because when you think about the biggest removal of a pain point, or it's the pain points. Historically, to enable some of these technologies, the pendulum swings between edge compute, central compute. That's gone back and forth 7 times that I can remember in recent years. And so to understand that there is another technology now available, ready, market ready, and deployed in commercial deployments that will allow you to not wait 2 years for fiber. When you think about the ROI of some of these projects, it's going to take you a long time to build and realize some of this cool technology. Now you can set this up in a day, not in 2 years. And so if you're looking for rapid piloting, or if you're looking for opportunities to install at a lower cost of deployment, that's what I think is really exciting. That's changed over the last 18 months, is now that there's a new technology of connectivity that will allow you to do this faster and less expensive.
So you're telling me we don't have to dig trenches anymore?
No trenches, no digging, no spectrum to license, and more resilient too, right? If you think about Houston a couple years ago, they had this great ring topography of buried fiber. You get one flood, it knocks the whole thing out for weeks.
Yeah.
And so what is resilience? You know, sometimes I think that that's a big pain point that is not necessarily addressed, how vulnerable fiber really is in the real world. It gets cut. There's more construction happening. And so what can you deploy that's going to be not just another fiber, which is also vulnerable, but how can you do it over the air, a different modality to get that same level of ultra high speed, 400 gigabits, a terabit of connection? How can you do that wirelessly?
So I live in Houston, and we did get that one flood, and we did lose all connectivity.
Next time,
so
call me,
real
I'll get
use
you.
case. Yeah, John, from your perspective.
Yeah, I think what I've seen over the past number of years has been accelerated development and growth of technologies. The biggest evolutionary change so far is the new NVIDIA stack. What they're doing deliberately from that connectivity, from the data source, all the way up through the networking side of it, through the cybersecurity side of it, all the way through what it actually can deliver. Without that integral, we'll call it a turbo power within your data center, it actually becomes more challenging in order to source that data. Everybody's operating in different environments, there's vertical silos. This is now a new horizontal plane that allows that to come together, to come into fruition, so we can make actionable intelligence, another verb of AI, out of the artificial information that we're sourcing, or not artificial, but sourced information that AI can turn into that actionable intelligence. Now, what that means is quite simply a better way to deliver results to the customers that they expect, and tying the systems together securely so they can be resilient, so they can deliver these outcomes, and do it at a lower price point, meaning the same investment, greater services to the constituents. So those are our main goals. We at SHI have a strategy, right? Imagine, experiment, adopt. You don't need a $100 million project. You need a 50K project that can prove your point to the person that will fund and sponsor that larger project. Start small, work closely with partners like SHI and other folks that are out there to help you execute on these specific vertical pieces. Otherwise, you got a bunch of instruments that aren't acting like a symphony. And what we want to do is create harmony and orchestration amongst, the different musical instruments, your percussion, strings, vocals. Thank you.
No, that's perfect. And you mentioned something, prove the case, right? Or prove it out. I think that's really important. And I started my career in IoT, and IoT was all about connecting devices. Very exciting. But I started realizing once you connect all these devices, all this data is sitting somewhere doing absolutely nothing, right? And to get to that business outcome was tough. This is why 70% of the IoT projects just failed, right? So I think AI is offering that chance to now prove that, hey, this data is leading to a business outcome, right? So it's becoming more realistic. So very exciting time. Jumbi, I'll come back to you. So I know vision is one use case, one aspect, right? We're talking about the full stack over here. So for NVIDIA, what does a full stack mean in the smart city space, right?
Yeah, that's a good question. So, to run AI in general, you need many components, right? One is the infrastructure layer, and we have a lot of partners like SHI that'll help you deploy the infrastructure that you need for AI applications. The more exciting stuff right now in terms of infrastructure is that Now you need only one infrastructure that'll pretty much run everything. The old days of very siloed infrastructure needs for different applications, if you have a graphics-based application like geographic information systems, you need one kind of server. If you have, agentic applications, you need another kind of server. If you have data analytics, you might have a third kind of server for, analyzing large amounts of data. Now with the AI infrastructure stack, all this is completely unified. So you can run all of these AI applications, physical AI applications, as well as agentic AI applications on a common infrastructure stack. And that common infrastructure stack is not just about the hardware, but more about the software. So the software that you need to run all these amazing AI applications is now integrated into one stack. So you can have, large language models, and lots of them are freely available. You can have vision language models. You can have all of these to create all kinds of applications on the top layer using exactly the same software and hardware infrastructure.
And when we had our prep call, you mentioned something that I didn't even think about it. You said majority of NVIDIA now is software focused, right? Like 70% or something like that. That's true. A lot of times when you think, you're just thinking microchips and microprocessors, but no, there's a lot of intelligence in that software layer. Yeah. Zev, I'll come to you. So NVIDIA has this full stack offering, or any company, right? How critical is it for the connectivity to be not just reliable, but strong, right? And how important of a role does that play, the connectivity over there?
Well, there are two layers of it, right? One is that you've got all the capability and you've got the software making decisions on the edge, but sometimes you want that to come back to a central location. And if you've got buried fiber and you've got a network of dark fiber, you've got that recurring cost, the OpEx associated with it. And so to John's point as well, when you start small, you start with a pilot, when you have to bury fiber to get the amount of speed to handle all this capacity, it's going to be a buried asset. It's immobile. You're not moving it anywhere. So if you're not going to move forward, or if you realize that you need it in a different community or an expansion community, your cost of the project balloons significantly. And so what this will allow is exactly what John talked about, is how you can structure a pilot at a very small cost with a movable asset that's not fixed. And it allows you, and what we just launched and announced today was 2 blocks from here at 360 Rosemary and 1 Flagler, 2 premier related Ross buildings, we've established a 400 gigabit per second link. And so that's just up there. We set it up in a couple of days, and that's providing resilience to power the interconnection between multiple of those buildings, where you just have otherwise a data center that's connecting one line to each building, not very resilient, but you can build a mesh ring instantly at a much lower cost than you can, and a much faster time period you can.
That's awesome, very exciting. John, I'll come to you. So a lot of cool vision from Jumbi, right? A lot of wireless visionary stuff. You're working in City Hall, you're working with the customers, you're implementing some of this stuff. Is this real, or are these guys making it all up right now?
No, it's real, but the most significant piece and the most important piece isn't what, like, let's say, for example, I can show you computer vision, right? I can show you stalled vehicle, color, make, model, nameplate. Great, but for what, right? The most important thing, and that's where, one of our key philosophies, I want to understand what the city needs to accomplish. There's 20 partners, 50 partners out there that can do the same job. I don't need to lead with a very specific thing, but what I want to do is deliver 8% reduction, right, in congestion, 15% improvement over greenhouse gas emissions, right, 12% improvement for emergency response times, as an example of traffic, right? There's plenty of other cases where we can use and understand what data is. SHI's approach kind of steps back and says, look, we have a 5-layer cake approach. And there's one dynamic of that I always hear forgotten or not mentioned: energy. When we do the small scale pilot, we can determine what the calculus is. How do I say this 4 buildings, I want to turn it into the entire West Palm Beach? I know how much 4 buildings cost over this distance. We now have a calculus to determine what the city will be spending annually, and it can be broken down into their budgetary cycle. Now we know how much energy will be consumed, so we can see if we have enough, or what do we need to do to change that. Do we need to put solar panels on the government buildings to reduce their demand from the grid by 8%, so I can pull the AI data center that's running with all this new stuff? right? Our 5-layered cake starts at energy, goes up to chips, then to hardware, the CUDA code, and lastly, the applications, right? All of these have to be aligned, like in that symphony that I talked about, percussion, strings, vocals, horns, right? They all have to come together if you want music that makes sense and is meaningful. And at the end of the day, the citizens, the constituents need to get a benefit out of whatever that project was. So we look at a long timeline, right? And make sure that that aspect is also included, like energy, but all the way up into, does that application deliver what you need? Does it talk to the other 4 applications, right? You can bake cookies, but can you do chocolate chip and oatmeal, right? Maybe, maybe not. But we're, and I apologize for all the analogies. It's just, if I could throw out an example there. Yeah,
Just skip lunch today?
Yeah,
No,
but
cool.
that's my response. So thank you.
No, that's perfect. That's perfect. That's a good example. I like your percussion example, right, where you have all these different instruments. But one problem I feel like I see when I was working with all the cities was they do have all these instruments, right? They're all siloed. They're all playing amazing individual music. It's very hard to get them to talk to each other, connect with each other, not from a data perspective, because all the data is in some cases proprietary, but outside of technology, from a politics perspective, right? From an operations perspective, a money perspective, right? So that, I think, is a non-technology challenge that we see cities run into. So Jumbi, I'll come back to you. Have you run into that? How do you see that being solved in some of the use cases? And who are the right people to talk to in the city?
Yeah, we run into that all the time. I'd say, there are 2 reasons at a high level that cities have a hard time with in terms of procuring new technology, right? One is, of course, the procurement process. And talking about silos, a lot of different departments have different procurement processes, they have different cycles, they have different requirements, they have different budgets. So yeah, that is a big challenge right now. And yeah, the second one is, AI, as John was saying, it's really only useful if you take all this information, put it all together, create the symphony, because if all the data from all the different departments doesn't go into a nice vector database, as we call it, that you can query to get useful information, doing it in silos loses a lot of value of what AI can actually bring. So in fact, every time we go into a city, one of the first things we do is say, guys, the old ways of doing things where you guys did your own procurement, had your own budgets, now you guys are trying to think of all your own AI applications, you gotta put that aside, because AI is gonna pretty much influence every department in the city, right? Every function in the city. So you gotta start thinking holistically from a high level. Like John was saying, what are the key use cases that you want to address? Safety, security, traffic management, infrastructure management, etc. And then start the conversation there. Then departments are a lot likelier to share information because they can actually see the outcomes that are going to affect them.
Yeah, no, that makes sense. John, when you're working with all these customers and stuff, do you run into that issue, and who are you working with to solve that beyond just the technology side, right?
Yeah, sort of, and there's no easy answer, but the key is to every project. So for example, if we're doing something with the police department, right, and you got the IT guys, they're all excited. You need a sworn officer that's a senior sponsor, and you align with that guy to get the buy-in. The IT guys will build the tool that makes their job easier, but if it doesn't satisfy what the sworn officers need, you're out of your league. And it's the same thing for fire, for city commissioner, and everywhere else. There's 2 major functions, right? Workforce efficiency, right? Or workforce productivity and operational efficiency. And those 2 aspects, those 2 dynamics or vertices per se, are what will deliver the outcome, right? And when we look at vertically siloed systems, the importance is creating a horizontal plane that allows workflow management, that allows service desk orientation, and agentic AI orchestration. And that, in concert, will allow those exchanges and that actionable intelligence to be delivered. So when we focus this, yes, the governments have a lot of different procurement processes. My question is why? Why do I need an IT guy at the fire department and the police department? When at the end of the day, the fire department has things that they expect to be delivered. I want to know where I'm going. I want to know what the fire looks like. I want all the information that I can obtained from that particular site before I get there. So I'm prepared and I can respond with the right number of people. I don't need an IT guy telling me which networking switch is better, right? Or how much storage do I need? When in fact, we went to this siloed thing. Everybody's got an IT department rather than a service request to a department that facilitates this AI homogenistic engine for the whole city. Give them results. Again, it's not yet adopted. We still got mindset of I need my own IT departments. But my question again is, when we're looking at these things and we're trying to take that one limited budget item and use it better, more efficiently, more productively to give better outcomes to the citizens, it's essential that we, frame that and put it in place together and start looking at all angles to save money so that the same budget can go further. Anyway, thank you.
No, that's a great answer, and there were no food analogies in there, I noticed. You skipped it this time. So one question for all of you. So AI is great, right? We're asking cities to implement more AI, create a lot of automation, do as much as you can with integrating your data silos and have everything talk to each other. What is the role of the human in the loop then? I mean, do we need a human in the loop? How do we keep AI in check? Where does some of the AI accountability fall? Zev, I'll start with you, and then we'll pass it down.
That's a little bit more of a Jumbi question
Yeah,
than ours.
I know.
We're layer 2 agnostic, so we're just the
Just your perspective.
But from our perspective, and I know there are a lot of municipalities in the audience that I saw, everybody raised their hand. I'm curious if you find more of an issue, and just by quick raise of hands, whether it's budgetary or permissions of being able to share that data, or maybe there's an other. How many people think it's more of a budgetary hurdle versus a okay, no one's saying budgetary, raising their hand on that. Is anybody raising their hand for permission level about the security of information? Security of information. Okay, so that's where our perspective will come in. As a layer 1 device, and it just stays, everything is optical, right? We don't have to do the electrical conversion. So we can enable quantum key distribution or quantum computing, quantum timing, to allow for that greater level of security so that you can, like any routing solution with Cisco or whoever, you can bifurcate those signals and have everything be secured with quantum key distribution that allow for permission layer up at the stack to software to get all the LLMs working with those consolidated systems without necessarily sharing the permissions that you need to share information across department. And one thing we saw public safety as well is that it's not enough just to get the compressed video. When we are talking about forensic analysis that the police need to do, is you need to see 8K uncompressed video so that you can do person identification. And sometimes if you don't have that higher resolution that the throughput of 400 gigs or beyond needs, you're not going to get the data you need to really make those insights actionable at central or post event.
Yeah, Jumbi, what's your perspective on the human in the loop?
Yeah, often when I start out doing presentations for public officials, I say, everyone talks about AI as being artificial intelligence. There's nothing actually artificial about it. It's actually real. So I say, think of it as assistive intelligence or augmentative intelligence, where it's going to help you do things you already do quicker, better, faster. I'll give you a great example. One of the best things that AI has done is automatic language translation. So for example, in some city halls, a citizen can get up. Like where I live in San Jose, there are people who speak 80 different languages. And access to the public process has been a barrier for people who don't speak very good English. Now you can go to a lot of city hall meetings, start talking in any one language, it'll display it on the screen in English, and then the city council person stands up and talks in English, and it translates into their languages. Now there is a translator to make sure that this thing isn't like going totally wacko, but it just makes it quicker, better, faster. So in a lot of cases, citizen services, licensing, permitting, etc., it just reduces the amount of time which lets city employees actually process more so they can get revenue faster. So
anything you can do to reduce DMV lines, I'll sign up for that. Anything over there. John?
Yeah, so no, these are great examples, and I think where I look at is humans will never go away. They're always going to be essential, but the human that uses AI is going to be the one that excels. If you're worried about losing your job, because you're not learning how to use AI to help you, and that's the key to it. AI will not replace a job; it will make things more efficiently. Okay. Now, I want to touch on your San Jose example. If y'all and some of the young folks forgive me, but if you remember Epcot Center 30 years ago, they had the dome thing, and you go up in it. and people would speak and it would translate, and they would have communications all over the world, and it would come out in your native tongue. So I thought that was quite interesting and very important. But if we look at the example of security and accessibility between different data sets, different government departments, one example I would bring up is like this. Let's say you just moved to the city. You want to get your kid enrolled in the school that's assigned to your house, right? The school wants to validate that you actually live at that residence, that you're who you say you are, and that you have this number of kids. How do they do that effectively without violating your privacy, right? And that's where sovereign data comes in, and security on how interrelated systems. I want to check with the Department of Motor Vehicles, make sure the driver's license ID and the person match up, right? I want to check with the police department to make sure this is the ID and the address, or the land department where they live. Police department has no right to say anything else about me except for, I'm John Lockhart, this is how old I am, and this is my address, as shown on my ID. That's it. Everything else is nobody else's business except for what the police and criminal system. So we need to make sure that as we interconnect these data systems, right, that they only share or exchange information that's secured and allowed. You have to plan for that. You have to build security in at that horizontal framework plane, way at the foundation before you start executing. Otherwise, you're just creating more silos and more systems that are not talking together. You know, you got a great new instrument, but the guitar doesn't go with the, you know, the orchestral. Anyway, thank you.
Yeah, no, that's great. So last question. I was just informed that each and every person in this audience is super excited about AI, and they can't wait to go back and implement an AI project. Someone just told me. But what would you guys give them as one takeaway, something realistic that they can go back with and start thinking about implementing? It could be, you know, something impactful. I'm not talking about like research and stuff. Just what's something real they can do with their current projects to make AI a reality for them? Zeb, we'll start with you.
I'd say to realize that the barrier to trying it is a lot lower than it has been in the past. When you can, if you don't have a dark fiber ring available that's going to have some recurring cost, you can go building to building. You can even go through Windows and LEED certified Windows with LaserComm technology. And so it'll allow you to implement and try something and really understand the cost immediately before you have to make the bigger commitment.
Jumbi?
I gotta say traffic. Traffic is my big pet peeve, especially in the Bay Area. And there are technologies available that do three things, and you know it's very easily implementable. It's not rocket science anymore. One which is reduce congestion, two which is increase safety, and three which is have a positive environmental impact because cars stopping at intersections pollute more. So all of these three can be addressed very easily these days with AI instrumented signals across the city.
Before we get to John, I just want to mention that if you had then a solution that required no trenching, no street closures, would that be valuable?
Yeah, absolutely.
There's a lot of internal selling going on over here.
Yeah, no, excellent, good answers. It still boils down to the two basic facts: workforce productivity and operational efficiency. So what I would suggest to you is we can start small and learn how to scale. Meaning take that single use case and build it bigger, and then expand to include additional and different use cases. Where is the inefficiency? You've got to look for a place where humans are spending time on something that could be automated, and that will free them time up to train additionally on AI, to do more and better things. We won't necessarily lose jobs, but look where there's a task bottleneck. And that's where AI is going to be the most benefit. And this could be with traffic. This could be with building air quality. It's different for each individual person. And our mindset, brain power goes behind your specific thing. And how can we help you accomplish a goal that improves efficiency? That's where AI is advantage. Not the guy processing the same thing every day. How do we autonomize that? How do we create a kiosk that's got a digital ambassador at community centers, at libraries? So I can free the staff up to do the other things that will provide greater services to the people visiting, or DMV, or things like this. You're seeing some of them pop up, but they're not interactive. How do we take 311 and make it a non-human thing? Because they're simple requests: acknowledge, document, report, and if they need a response, a human's alerted to what it is. Otherwise, the workflow is automated. Pothole in the road, this guy is going to drive out there and fix it in 4 days. It's been scheduled. Something like that.
No, that's perfect. So yeah, thanks a lot. What I got out of this conversation, and I'm hoping you'll take away as well, is the gap between a reactive city and a proactive city. It's not technology anymore, right? The technology is there with all these pieces and all the vendors over here. The capability to do stuff is there. I think it's just a matter of having a systems approach, having all these pieces work together, changing our mindset so we can start thinking along those lines and having some actionable outcomes that we go after, right? So I think, I'm hoping this conversation has excited, energized everyone to go back and look at their projects and see how AI and technology can help fasten them. And I want to take an opportunity to thank everyone. This is awesome conversation. Thank you for being here. And we're looking to have these conversations with you on the floor as well. So thank you all for being here. Really appreciate this.
Thank you.
Thank you.
Thank you.